In this video, I will be explaining how to obtain a nominal rate of interest if we know the effective rate of interest. And we are going to use this example. What nominal rate compounded monthly is equivalent to 4.8 effective rate? So if we have a rate that gives me 4.8% yearly, what will be the nominal rate of interest compounded monthly that produce the same future value? So in this problem, we know the effective rate of interest, that is 4.8, and we need to compute R, the nominal rate of interest, but this nominal rate of interest compounded 12 times per year, compounded monthly. So M equal 12. So we can use the formula of effective rate of interest to make this computation. And we know that the formula of effective rate of interest is F equal 1 plus I to the power M minus 1, when this M is the number of compounded periods for this I. This I is the periodic rate of interest, that is the nominal rate of interest divided by the number of compounded periods, in this case divided by 12. So we can make a substitution. This negative 1 here can be written at the other side positive, 1 plus F. So we can write 1 plus F equal 1 plus R over M to the power M. If you notice, this thing here is the amount that you receive as a future value if you invest $1 at this effective rate. So after 1 year, you are going to receive 1 plus F. But if you get the nominal rate of interest after 1 year, if you have this nominal rate of interest after 1 year, what you are going to receive is 1 plus R over M to the power M. So this is actually the formula of the future value of investing $1 per 1 year. So this actually two different ways to find the future value of investing $1 per 1 year. And we can start from this formula. So we know in this case that F is 4.8, so we can write here 0.048, or adding 1, this addition is always easy, adding 1. So you can write 1.048. And the other side, you can write here R divided by 12 to the power 12. So making a substitution, you find this. So this will be always at this side 1 point. This rate of interest 0.48, 1.048. And at the other side, we have the nominal rate of interest divided by 12, because in this case M is 12. So we can solve this equation for R. And that's it, what we need to do, solve the equation for R. This equation is always easy to solve for R, because you can, for example, divide, in this case, divide by 12 both exponents on both sides of the equation. This number have exponent 1, this side of the equation have exponent 12. If you divide by 12 the exponent, here the answer will be just 1 plus R over 12. Because the exponent will be 12 over 12, it will be 1. This side will be 1 over 12, the exponent. So we're going to have this 1.048 to the power 1 over 12. So the exponent that was 1 is now divided by 12. And here the exponent that is 12, you divide it by 12, you get 12 over 12, that is 1. So this exponent, you don't need to write this exponent now. So you can actually write 1.048 to the power 1 over 12 equal 1 plus R over 12. And this now, this 1 that is positive can be written at the other side negative. This 12 can be written at the other side multiplying everything. So solving for R, here you get that R will be equal to 1.048 to the power 1 over 12 minus 1, everything multiplied by 12. So you're going to have this. So this 12 is now multiplying the other side. This 1 was first going to the other side, subtracting, so minus 1. And then use your calculator to compute R. I used my calculator, and what I found is 0.046975292. Obviously, the answer must be given in percent, so you multiply by 100 and type percent. So multiply by 100, you get 4.69, and round it as many decimals you are asked to round it. I'm going to round it to 4 decimals. So I will be saying that R equal 4.6975%. Let's make another example. So every example will be in a similar way. So let's see another example. One nominal rate compounded quarterly, now the nominal rate is compounded quarterly, is equivalent to 7.2% effective rate. You have here that the effective rate is 7.2%, so this is the effective rate. You need to find R, but you know that this R, this nominal rate of interest, is compounded quarterly, so M equals 4. So you compound 4 times per year. And then you start from the formula, so you know that this minus 1 can be written at the other side as positive, 1 plus. So you can add 1 both sides of the equation, and you get this 1 plus F equal 1 plus R over M to the power M. Then this addition is always easy. This F is 0.072. Add 1 will be 1.072. And this M is 4. So you can make a substitution. You can write 1 plus 0.072, or you can write immediately 1.072. And then divide the exponent by 4. So this exponent will be 4 over 4, and here will be, the exponent will be 1 over 4. So you have this. So you divide the exponent both sides by the same number, and obviously you divide by 4 in order to eliminate this exponent. The exponent will be 1, and you don't need to write it. So it will be 1.072 to the power 1 over 4 equal 1 plus R over 4. And then this one go to the other side, subtracting and multiply everything by 4. So you know that then R, it will be equal 4 times 1.072 to the power 1 over 4 minus 1. And then use your calculator. 4 open bracket 1.072 to the power 1 over 4 minus 1. This 1 over 4 is 0.25. You can write 1.072 to the power 0.25 minus 1. Close the bracket, and that gives you the answer 0.070133813. You multiply by 100 to type it in percent. So type multiplying by 100, you get 7.0134. And that finished my explanation of how to compute a nominal rate of interest from an effective rate of interest. If you know, obviously, the effective rate of interest, and you know how many times per year the nominal rate of interest is compounded. Okay, with this I finish my explanation. Thank you.